name is Rick Steele, and I'm the plant manager of the casting plant at Olin Brass. What makes Olin Brass successful is a combination of the pride and heritage in the workforce and in improving our job, and then the leadership providing the right direction and guidance, putting a vision and values in place that is consistent with progressive and proven companies.
So it doesn't just fall upon the sales force to go out and find what the customer wants. That message gets taken back to all of our operations. My name is Bill Toller, and I'm the president of Olin Brass Mill Products.
I'm Steve Van Hoos. I'm the marketing manager for 5 Minute Tube in Cuba, Missouri. One important part of 5 Minute Tube being part of Olin Brass is that we're supported all the way back to raw material, through the casting, through the brass mill, through our metals research laboratory, and we have all these resources and alloy portfolio and different things that we can bring to bear to find solutions for our customers. We have a broad range of products in the tube industry, from aesthetic applications that are highly decorative with high quality of surface finish to heat exchange.
My name is Tom Warner, and I'm Vice President of Marketing and Sales. I think it's been innovation as much as anything. You have to continually reinvent yourself. And that Olin Brass in its own way has been doing that for 100 years now.
My name is Kevin Benzie. I'm the Vice President and General Manager of the Summers Stem Strip Division of Olin Brass here in Waterbury, Connecticut. Summers was started on this site in 1909 by the Summers family. They operated until 1967 as a privately held company when they sold it to Olin Brass. They've always been a very niche player, trying to produce very thin gauge metals to all kinds of different applications. We're producing light gauge copper, and as electrical components and pieces become thinner, that's where we come into play.
We're in a unique position to offer our customers everything from the raw material strip products to even downstream fabricated products, and virtually in any quantity and any shape that they require. So we can meet their needs as customers are constantly changing. Their ability to predict and forecast is very difficult today in this environment, and I think that's what Olin Brass has done very well, is bringing that to market.
Olin has historically always been a technological leader. So the development of alloys, development of applications, rolling processes to make the product form better, to work better for customers' applications is essential. This company, another 100 years of life, is to work on the culture of how we work, of how we engage everybody in their work, and how we can develop business processes and systems that are founded upon the people and how the people work together as a team. And the culture is the most important piece, because the culture is that of a continuous improvement mindset, and by having that mindset, we're always looking for those opportunities to improve. Olin Brass is a company with an environment that's looking to build something that can last at least another 100 years.
Welcome, my name is Erick Epperson. I'm with Olin Brass. Global Brass and Copper is our parent company. On the left side of the screen is my company. We have two sister companies. One's called A.J. Oster. It's a distributor of copper and other metals. We supply them, but they also acquire from other people, other companies. Chase Brad is a rod company. But the rest of this presentation is going to be around Olin Brass and our lean journey and bringing on MII. We have two research laboratories, one in East Alton and one in Waterbury. So we develop a lot of patented alloys. A little bit more about us. This is real exciting. This is a new product that we're launching primarily this year. It's called Cavero.
but it essentially kills 99.9% of the germs that touch it. So this could be a real game changer. If you can imagine public restrooms, operating rooms, places that get cleaned because they have a lot of people touching them, but you clean it once or twice a day, what happens in between? Within 2 hours, bacteria on this surface will die. So we are developing it. These are companies we're working with to develop products. So you'll be seeing that soon. And this is a little bit more specific to our process so you can understand our need for MII.
I see the hamster wheel spinning.
Needs more IT guys around here.
Quick, maybe hand puppets. What's this?
In 1916, the first bar of metal was cast at the mill Franklin Olin, built here in East Alton, Illinois. While just about everything from the original plant has changed in the century since, it remains the best place to get a real sense of what Olin brass is all about. Today, the Olin Brass Mill is one of the largest and most productive facilities of its kind in the world, covering 300 acres, employing 1,000 people, and capable of turning out over 1 million pounds of finished copper alloys per day. Now let's take a look inside and see how it's done. Formulating and casting the alloys is where the heavy processing stage of production begins. First, virgin and scrap metals, primarily copper, zinc, and tin, plus smaller amounts of other elements, are heated to their melting point, requiring temperatures of up to 2,300 degrees Fahrenheit, or about 1,300 degrees Celsius. Next, the molten metal is cast into large ingots, which are then heated and hot-rolled in multiple passes to elongate and reduce the ingots to a thickness of less than 1 inch. Then, high-speed milling and breakdown rolling processes produce a continuous metal strip, approximately 30 inches wide and less than 1/4 inch thick. This metal strip is wound into coils and prepared for intermediate processing. This stage is dictated by customer specifications, the required chemical and mechanical properties, the specified gauge or thickness, and the surface characteristics required for their applications. Each alloy undergoes its own unique intermediate processing plan, which includes cold rolling, annealing, and various cleaning techniques. Once completed, the alloy is just a few finishing touches away from delivery. Final steps may include coatings, plating, or other surface treatments requested by the customer, as well as tension leveling, slitting the strip to width, or cutting it to length. Various packaging requirements can be accommodated to meet customer specifications as needed. Finished, high-quality copper alloys can be packed in a variety of ways, as coils on pallets, stacked in sheets, or traverse wound onto spools. Ultimately, the product is shipped off to Olin Brass customers across the country and around the world. Those customers include OEMs and supporting companies in the ammunition, automotive, coinage, builders hardware, electrical, and electronics markets. And of course, they also include all of the other Olin Brass operating units, as well as our international subsidiaries and joint ventures. But as diverse as our customers are, they all have one thing in common:
They all demand the highest quality copper products and most reliable service in the business. From a company that makes doing business as easy and problem-free as possible. That's what Franklin Olin had in mind when his mill opened in 1960. And that's what Olin Brass is still all about today.
This is production execution if you've got SAP Core, but it could really be any legacy system. Two things I'd like to focus on. First is the production user, and then the quality user. For the production user, without MII, he has to interact with some production system, a quality system, a document system. Some of it's in paper, so he has to be an expert in all these subsystems. The quality user, if you have a reject and you're trying to research something, you have to go to various systems to try to retrieve the data. So in manufacturing, those are kind of two important functions that we're trying to address with MII. It becomes the one point of contact so that regardless of what system's around it, whether it's SAP or a legacy system, that user is going to get used to one face, one way that will access the proper speeds and temperatures for that machine, for that step, because if there's been a revision, it's been updated into the database and he doesn't have to go search for it. So you have control systems, you have an integrated tool, you have better compliance, you have better metrics, all the things that are essential to Lean. So now that production user doesn't really care about the other systems. He doesn't have to know anything about them. He just has to become familiar with MII. Same for the quality user. So right now, one of the quality users or an engineer or customer service, if they want to track down a problem and get to the specifics, they have to go into various databases. It's time consuming and it's not particularly friendly. Now, our company is going down the Lean path. Started about 2 years ago, so one-piece flow, standard work, pull systems. So Lean is all about velocity, getting things going through the plant faster, lower inventory, shorten your lead times. And there's two pillars of that, continuous improvement and the people side. And as we roll out these projects that sound great, if you don't concentrate on the people side, you're not going to get very far. So you have your project management, which a lot of us are involved in, but the change management becomes just as important and probably a bigger challenge than just introducing a new system. As soon as you hand it off, it may not work. Operators, supervisors, middle managers, project managers, upper managers, executives. Which ones have the most influence and change? We're using a company called ProSci, and if you want a change management system to look at or think about, this is called ADCAR. But in this it says the ones that can influence change the most is the middle manager. He becomes the face of the company to an operator. So the middle manager has the most influence. Who has the least influence of that list? It's project managers. So if we're going to try to implement a system and we're talking to the operators trying to convince them how to use it, it's not going to work. It's not likely to work. Project managers are the most receptive to change because that's kind of what we do. The least receptive to change in that same group, middle managers. So the ones that are most resistant are also the biggest influencers. So if you don't have a system to engage them early on in the project and to communicate the constant message throughout your change process, your likelihood is not going to be very good. There's definitely a direct correlation of the success of rolling out projects when you have a change management system. Most companies, change management means this is how we control our documents, and we'll rely, we have good people skills. So it's not really a system. Okay, now let's get back to visual management, which is part of Lean, and that's the flow in getting everything going through in a normal fashion and fast. When you have variability and it goes out of spec, that's where the Six Sigma part comes in. That's where you do a study and have the analysis, and that requires a lot more data, organized data. But as we go on this lean journey, we're not waiting for MII to show up and fix all our problems. This is the operator to the number 8 strip anneal. That strip anneal is 3 stories high and 100 yards long, and he's the only operator. So he needs some tools to run this and take care of problems. So even before we get MII, you see the lean tools and some quality tools showing up just because there's such a big need. Now, with all of these different systems, it's not integrated, it's not consistent, but they need something to work with. This one in the lower right, that's just saying the speed of the machine. It has a standard, and just putting that in, there's an immediate productivity improvement. The plant manager can see that from his office. That's a 50-inch TV screen. So visualization works, but it's not optimum yet. Turn it over to Brian. Brian Kuzinski.
Hi, everybody. I'm Brian with SeeIT Solutions. I wanted to give you a little bit of an idea. Erick spoke a lot about, give you some ideas about what Olin does, the processes that we're working with, and the lean journey that they're on as a company. I wanted to talk a little bit more specifically around the MII program that we're putting in place, the projects that we've done, and give you an idea. As Erick said, the manufacturing process is not waiting for MII for anything to get there, right? There's a need out there, there's a value proposition, so they're starting to see point solutions come in. And what we want to do is make sure we tie those in from an enterprise standard point of view and make sure that we provide one solution for the shop floor when possible. So give you an idea here about kind of how the project has evolved. It started with a foundational process, and that was a product selection. Olin already had historians in place to collect data out of their automation. So they looked through different products, what was needed. There was an SPC need, there was a visualization need, there was a SAP, an upcoming SAP implementation, and that's something we haven't really talked about. Olin has SAP right now, but it's only in PM. They're currently blueprinting PP, WM, QM. And so they knew that SAP ECC was coming in place. They also knew they had all these needs and a value proposition on the floor for shop floor information. And so what was decided is that we would go ahead and install MII ahead of SAP, ahead of ECC, PP, get the users used to using those systems, the shop floor operators, so that when ECC happened, the transition was fairly seamless. There's going to be some changes, we're sure, but not a whole lot of difference because the face to ECC for those operators is MII. It's the same paradigm that was put in place. We did at Gatorade, also same thing. So it's real. There's a lot of power to that. After the foundational decisions were made that we would start in the strip anneal process, which is where they take basically coiled rolls and transform them a little bit, as you saw in the video. We've done a design and a blueprint, done the wireframing activities, onboarded key users, and worked through our acceptance process in OCM. We did our development in an agile format, and then we did an all-sprint implementation. It was interesting as we did our first project in strip anneal. Other projects started hitting us all along, and we were bringing on additional development teams to work within the foundation. One of those was around an enhanced brass mill reporting. So they saw a need to do a little more QM, or a little more hold and disposition reporting, and we were able to bring that into MII in a really short time frame because the framework was already in place. Our next area that we're going to is the casting plant. Then, of course, we're going to be involved in the full blueprint as we hook MII into that ECC implementation, do confirmations, production schedule downloads, material movements, all those kind of things. I'll give you an idea. I wanted to talk about just a little bit about PARS, their production and reporting system, which is their shop floor system, the main objectives. And the biggest thing was to provide a birth-to-death genealogy report of the production order as it passed through up to 19 individual processes at Olin. So this included things like downtimes, process values, any inspection results, operator notes, quality notices, all those things, basically a one-stop shop for all that information. Rather than going to this system, this system, this system, and this system, it's all in one place. So they can put in a final order number and basically get the genealogy of all the process and operator information as it went all the way through the different processes in the mill. We wanted to add and visualize context for the production KIVs. We wanted to report and record all those KIVs, which are their process values, and any excursions, so when they went outside a set point. We wanted to create an electronic logbook, so everybody, most plants have a logbook out there. Everybody writes all their stuff in it. Maybe it's safety notices, maybe it's startup information, maybe it's a quality value or an excursion. But a lot of times that stays in that book. So we wanted to place an e-logbook, if you will, for people to go search and get this information. We wanted to increase the visibility of the supervisors and managers of the real-time production KPIs and events that occurred. So a KPI is a downtime, it's an OEE, it's those kind of things. And then, of course, prepare the foundation for the upcoming ECC rollout, which was production schedule, routings, confirmations, those kind of things. So MII had a really good fit here. This is the landscape as it exists. My guess is it exists the same way at many of your facilities. You've got MII in the middle. You've got an SAP instance. In their case, there's the SAP instance currently being used for PM. They've got an ERP currently called Tandem. It's going to be replaced by ECC. That's got their orders, specs, and history. We've got metallurgical databases that have testing and specifications. We've got a LIMS system for inline lab results. We've got other plant databases out there, as you can imagine, product disposition, startup parameters. You know, as you guys, most manufacturing facilities has stuff all over the place. And MII is a great aggregation source to bring that all together. Inside their plant historians, quantitative process values like pHs and temps, as well as production process information like speeds and downtimes. Their SCADA systems. And then one of the big keys here is we weren't going to be able to have the capital to go automate everything. So we still needed a way to manually pull in information and have that look like any other automated piece of information, just at a lower resolution. So PARS does that with manual data. Just a couple quickies here. I always hate it whenever I go to a presentation about a system and I never get to see what it looks like. People talk about the methodology and all that other stuff. I always wanted to know what it kind of looked like. So this is what PARS looks like from an operator dashboard standpoint. The middle is an animated, the middle pane is an animated area of that area. So this is the strip anneal line 7. Stuff turns red and green based on process set points. Those set points are material specific. So depending on the material they're running, those set points change. MII knows that. MII also puts that into an SPC charting capability, which we'll see a little bit later on. Those set points have a couple different ways to alarm. They can either be absolute, so like plus or minus 1 or 2, for instance, or a percentage. And they can be either based on material or static at all times. Right-hand pane, if you select any of the center pane items, you get the exact KIV information in the right-hand pane. So I can't quite read it, but whatever that is selected there on the right shows a concentration and a temperature, I think. In the middle is the KPIs. That's downtime, bars ran, and other things like that. And the bottom is a listing place. So that's where you're going to see all excursions, which are when a process value goes out of process or out of control. Downtime events, operator log entries, and any notes. we'll just skip through here a little bit. I told you that we're getting as much information as we can out of automation. This is how you manually input a value in if you don't have a PLC hooked up to it. Real simple, real easy. We can also alert and alarm the operator, hey, it's time to go take this measurement, hey, you're late, those kind of things. At the end, so this is where some of the workflow capabilities of MI comes through. When a bar is done running through the strip anneal process, there's some final processes or some final inspections that need to occur by the operator. Those get tagged just like any other KIV, any other value, and that's the final bar review. We lead the operator through, were there any scuffs, was there oil on the finish, those kind of things. Where was it at? And this is all dynamically driven out of the database, so so Olin can change it as they need to add reasons or add steps in the process. These all get tagged, like I said, just as any other KIV would get tagged, and becomes part of the, it's not really a device history record, but a bar history record for that bar as it sat in that process. And we do this in every process that they go through. We print out a final bar scorecard. Basic information, I know you probably can't read it. Basic information at the top. Process values in the middle, including SPC analysis of those, mean, average, stuff like that, and event listings of those excursions at the bottom. This also determines if the bar, if it has excursions on certain values that are dynamically chosen, that bar will automatically be put on hold and then has to be dispositioned. I think finally, let's talk about, Eric talked about whether you're a CI person or a quality person or a customer service person. This is where you go to get your information on how that product ran through the manufacturing process. You enter some information at the top, some selection criteria, what you're looking for, if it's an alloy, if it's a time frame, an area, and out of that selection shoots all the information that was collected for it. You can export it to Excel, export it to Minitab. You can look at an SPC view like you have there. So that's the power, and this is all MII and all kind of what's included with MII. So like I said, just want to give you a quick overview of what the process looked like and what the project outcome looked like. I'll let Eric finish up here a little bit.
Thanks, Brian. Okay, going down the lean journey, eventually you're going to run out of steam. There's going to be low-hanging fruit that lean can address, but at some point you've got to reduce the variability, and that takes a lot of data. And this is the DMAIC approach, Six Sigma approach. A little bit of difference between the two. Lean is to create flow, eliminate waste. Six Sigma, again, is broader, a lot more science involved into it. At Olin Brass, we use what's called A3 thinking, which can accommodate both lean activities and Six Sigma. So this is our method that everyone's trained on and is used to working with. Here's an example of the A3 for one of the events, but it's a organized process. Why do we analyze data? Because what you see is not always what's really there. It takes the assumptions out, and so why do we need all of this data? Separate what we think is happening from what's really happening, confirm, disprove ideas, theories, establish a baseline, a starting point, and see how the history reacts over time, trends, make a change, and then see what the impact is, understand cause and effect relationships, and react to the process. Organized, easy to access data helps spending time on breakthrough ideas. The engineering staff spends more time finding and solving issues and less time as data mining experts. There's a shortage of engineers always. So use their time to be engineers. There's fewer and fewer graduating every year. The ones that you do have, give them the tools to do what they need to do. Have the right time at the right moment, the right information at the right time to run the product. Systems that aren't integrated are going to cause you production problems, excursions, things will fall through the cracks. Paper systems, handwritten notes on the production orders that are following through. don't really help a lot. So that's the highlights. Video or?
I guess we got a couple things. We got another little short inspirational video to show, but before we did that, I want to know if there were any questions out there. Yes, sir. Oh, go ahead.
Here comes the mic.
You call them out.
I'm interested in how I saw the input of notes. So I'm guessing when things didn't go as planned, any variation, that's a manual kind of input. How does that aggregate down maybe the next time that same material master or product comes through to actually use that information? Because like our company, I'm sure others, we have an aging workforce who want to capture that tribal knowledge and use it as we go forward.
When something's going through a machine, it pulls up the specs that it's supposed to be running at, and we start recording excursions. Some of them are manual, but it's a drop-down list. There's very little of text. So off that drop-down list, we've got a list of all the possible things that can go wrong. So we can Pareto that and see trends and organize it that way.
In addition, all that data is completely searchable and available via not only the Pareto charts, but also just an open search criteria. So you're exactly right. One of the big things, there's a couple things. An aging workforce, you don't want to keep retraining on how to use this T code, that T code, and another T code. So MII kind of gives you more like a common web. Nobody teaches anybody how to buy something on Amazon, right? So MII is real native about that. In addition, it lets us kind of gain that tribal knowledge, hold it someplace, and then be able to show it and deliver it to other people.
Without MII, the tribal knowledge, the operator, I've been here for 30 years, and I know this particular alloy should run a little slower because the lab's going to tell me I need to do it anyway. But when you have the standards, you discover if he's right or wrong. And then everyone has to do it the same, which brings in the change management. The operator that's been there for 30 years, have anyone of you heard of the bereavement curve? If you have a significant loss, there's anger, denial, self-blame, blame others, that whole angst curve. Well, you got someone that's been an operator for 30 years and everyone looks at him, and then you give him this and say, you're just like every other operator. You have to run it exactly the same. No more diving catches to save the day. He suddenly feels like he's no longer as valuable. So the change management piece and getting this all in. One other thing I'd like to mention on the alerting to kind of think about this and how you use the data. For the operator, we didn't show one, but it goes yellow before it goes red. That turns on a light. So he looks at the screen and he can still save the product. On an iPhone, the supervisor gets a text message saying, go look at the machine. The plant manager has a different view. We didn't have time to show all the views, but the plant manager has each machine red, yellow, or green. If he sees one yellow or red, he can drill down.
Eric, I can imagine that the requirements when you first started the project were pretty broad. What was your process to define the scope of those requirements for MII?
If anyone's heard of strengths finders, it's the skill set that you bring to it. Well, my main strength is activator, and you don't need a lot of information. You just go forward and keep pounding, and you learn as you go. So we spent a lot of time. The users were so used to ancient legacy systems, they couldn't visualize. Even though I could show them, I could explain to them what it was doing. 2 months later, they're like, why don't we do something else? I want to do this. And so the buy-in is taking a lot of time, getting alignment, and that's why we are not just, here it is. So it's a slow process. It's hitting this identifying what the resistance is and keep going after it. And we are upgrading and changing it slightly to accommodate new ideas because they didn't know what they didn't know. So yes, it would have been nice to have 6 months, all the requirements. One of our project leaders tried to do that, and it was just not getting anywhere. So we just said, put it out there and we'll modify as we go.
The other thing, as I don't know if everything you've done is waterfall or if you've done some agile implementations. As you do an agile also, because the way you have to structure your sprints, you kind of start taking all the requirements that weren't and you stick them into a parking lot anyway. So really all the requirements are coming in and getting allocated according to what the steering committee sees for the value proposition and then where we can fit them in within the development cycles that budgetarily can be approved. And that's kind of the mix, if you will, I think too, from a project management. I'm going to do this, this, and this.
Hi, I've got a kind of three-part question here. What version of MII are you running? How long did it take to deploy? And also during the deployment phase, what were the biggest surprises you uncovered, either with the product or your processes?
Okay, so I'll answer all the technical ones. We're on 12.2. The deployment has been about 10 weeks. Once we got our scope down of what we wanted to do. Now, there was probably 6 months of all the requirements gathering and, trying to get alignment. We did do quite a bit of wireframing to, as Eric said, to give people an idea of what this might look like. Because there were some of the key operators who just couldn't conceive what this might even be. And so we wanted to wireframe it, get some ideas, pull those back. So we used wireframing. But it's been, I guess about 8-10 weeks on the deployment side for this process. Now we have more processes to come.
I think the real answer, though, is that the implementation never ends.
Yeah, very good.
You continuous improvement, find different capabilities and different things for analysis, things for operations. We've hired our own internal guys to be able to continually improve this package. So it's a permanent piece of our continuous improvement.
Why don't you speak to the surprises? Because we do many projects, and I don't get all that surprised that much anymore, but I'm interested in Olin's surprises.
No real major ones, other than someone thought it would do something and it looks different than they wanted, and why doesn't it look as pretty as a really cheap package that's really good at this one visualization. It seems like a lot of our people are, just visually oriented, and if it doesn't look exactly like what they're used to, that change is uncomfortable for them. So the MII process hasn't been, there's been a few things that we thought about, gee, why didn't we do this at the front? The yellow before the red. Sounds real simple, but that's a big thing. Having yellow alerting means we still can save the product. It's not out of spec, it's just a control about to go under control, so we can react ahead of that. That's a really powerful tool, but that wasn't in the first part. So
I think my biggest surprise would have probably been the fact that as we kept going down, we kept bringing more and more people in, and we kept finding more and more isolated silos of information that were as far as that person was concerned, was critical to shipping. Was critical to, you know what I mean? And so we kept pulling more and more and more information into it. I think probably a week before one of the development sprints, we found a new specification database that had to be incorporated that 94% of the people didn't know about. So I thought that was interesting. Shows the silos.
This is getting our metadata ready for SAP. Our lab, 95% was in one form, and we were ready to go forward, but that last 5% is in a different system. And, well, let's move it over now.
And I'd say there's probably some advantages to that too. We've been on several projects where we're putting MII in at the same time as ECC, and production always gets kind of pushed to the end, and therefore gets really strangled on how much time and resource it gets and never really gets fully understood. I think this is getting a lot of people who are on the blueprint team to think about the processes, where the information is, and master data pools ahead of the ECC blueprint and implementation. So I think there's probably some advantage there too.
Oh, one more question.
I'll do the video on the way out.
There you go.
This is kind of a follow-up to the presentation yesterday, so that's where my question's coming from. But did you, it sounds like to get the measurements in, there's a lot of this tag data that has to be set up, almost like master data for MII. And do you have like people that own certain tags, or how are you controlling when you make a new tag, and who all agrees to what's gonna be in there? And then the second, which is real similar, is with the KPIs that are getting defined in what you wanna catch. It's the same thing. Who owns the measurements, and do you got like some kind of control, or a department kind of control over those things?
We have a plant historian, and if there's an electronic signal coming from an electrical meter or any of our machines, it's being dumped into there, and we have a structure before we came to MII. And so we have the electronic, all of these different systems, Tandem, our mainframe, some other systems. There's an IT owner that knows what the data is and where it is, and then we have a team. There's a project manager on the IT side that's involved in here. We've got the senior developer on our side. I'm an operations guy, and I'm in charge of making sure the plants play along well. And then we have the SeeIT team. So we're working through each issue as we come along, as we're implementing.